Let's discuss this question. If A equals this matrix and I is the identity matrix of order 2, show that this matrix is equal to this matrix times this big matrix. Okay, that's what we are supposed to prove, show that, right? How do we approach this question? We'll have to simplify the LHS and RHS separately. Let's try to do that. Okay. So, what do we have in the LHS? LHS is I plus A matrix. What is I matrix? I is identity matrix of order 2. That will be equal to 1, 0, 0, 1. What is the matrix A equals to? A is equal to this 0 tan alpha by 2 minus tan alpha by 2, 0. This is my matrix A. Let's multiply them together to get the value of LHS. This 1, 0 gets multiplied with this. 1 times 0, 0 times tan alpha gives gone 0. 1 times minus tan alpha by 2, 0 times 0 would be minus tan alpha by 2. 0 times 0, tan alpha by 2 would be this. And 0 times minus tan alpha by 2, 1 times this is actually completely solved. This is pretty easy, right? I plus A is pretty simple. Just a minute. We were supposed to find I plus A, not I times A. Oh, bad. This is I plus A. We're supposed to find I plus A in the LHS, right? We have to add these matrices, not multiply these matrices. Okay, let's add them. 1 plus 0 is 1. 0 minus tan alpha by 2 is minus tan alpha by 2. This is 0 plus tan alpha by 2, which is tan alpha by 2. This is 1 plus 0, which is 1. This is what I have, right? Sum of the matrices I and A. It's not product. Let's not miss that plus sign over there. What else? In the RHS, we have I minus A times this matrix. Okay. So the RHS has I minus A times this matrix over here. What does that become? This is I minus A. Now this minus this, can I write that directly over there? Yes. 1 minus 0 is 1. 0 minus of minus becomes tan alpha by 2. 0 minus tan alpha by 2 would be minus tan alpha by 2 over here, and 1 minus 0 would be 1 over here. This is the matrix. And what's the other matrix? The other matrix is cos alpha minus sin alpha, okay, sin alpha and cos alpha. That's what you have, right? That is the RHS for us. Okay, let's multiply. Now here we have to multiply these two matrices. As you can see, there's a product sign over here, right? There's a product over here, and yes, therefore these matrices have to be multiplied together. Let's do it. This is 1 times cos alpha, which is cos alpha, tan alpha by 2 times sin alpha. This is plus tan alpha by 2 times sin alpha. Okay, this is what you get. We'll require some kind of a trigonometric simplification. Yes, we'll do that. What else? This 1 gets multiplied with this minus sin alpha, tan alpha by 2 times this plus tan alpha by 2 into cos alpha. This is what I have. This is the matrix that I'm obtaining. What else? In the second row, what you get is minus tan alpha by 2 times cos alpha. Okay, plus sin alpha. What about that term over there? That term would be minus tan alpha by 2 minus sin alpha, which will be sin alpha times tan alpha by 2. Okay, plus cos alpha. Pretty interesting. How do we simplify these terms? How do we go about simplifying these terms? Let's take a look at that. Tan alpha by 2. Now what is tan theta equals to? Tan theta is actually equal to sin theta upon cos theta. Yes. So I can write tan alpha by 2 as sin alpha by 2 upon cos alpha by 2. Okay, what's the big deal in that? That's no big deal. But once I write this sin alpha by 2 upon cos alpha by 2, we can take the LCM of this, right? Okay, so there's a cos alpha by 2 in the denominator over here. Yes, that's what I mean to say. There's a cos alpha by 2 in the denominator over here, and let's simplify this term. So sin alpha by 2 by cos alpha by 2, what will that be? We'll take the LCM cos alpha by 2, and this becomes cos alpha by 2 plus this numerator is sin alpha by 2 sine alpha, right? Take a look at this term very carefully. Take a look at this term very carefully. What you have in the numerator is cos alpha by 2, sine alpha by 2 plus, right? So this is cos A cos B plus sine A sine B. What is that equal to? Cos A cos B plus sine A sine B is actually equal to cos of A minus B. Okay. So this term here in this first term here can further be simplified and written as this term. Let me write it over here. This term can further be written as cos of A minus B, which is cos of alpha minus alpha by 2. What you have in the denominator is cos alpha by 2. Cos of alpha minus alpha by 2, what is that? Cos of alpha by 2 in the numerator and cos of alpha by 2 in the denominator. And yes, that is equal to this one over here. Okay, the LHS and RHS first terms seem to come out to be equal, right? Similarly, we can simplify the other terms as well. Yes, let's try to simplify this term. What you have is minus sine alpha. Tan alpha by 2 can be written as sine alpha by 2 by cos alpha by 2, right? Let's take the LCM as cos alpha by 2 over here. Denominator, in the denominator we'll have again cos alpha by 2, right? This is sine upon cos. This will be sine alpha by 2 cos alpha over here. What about this term? In the denominator you had cos alpha by 2. On taking the LCM, this will become minus sine alpha cos alpha by 2. Listen to what I am saying carefully. This is minus sine alpha cos alpha by 2 plus sine alpha by 2 cos alpha. Or read it as sine A cos B cos A sine B. Sine A cos B minus cos A sine B. Sine A cos B minus cos A sine B, sine A minus B, right? So this will become sine of alpha minus alpha by 2. In the numerator, denominator by divided by cos alpha by 2. Yeah, this is the denominator. That is all. Yes, that is all in the numerator. Now what is this simplified to? This is sine alpha by 2 upon cos alpha by 2, which is actually tan alpha by 2. Which is actually tan alpha by 2. Okay, there should be a minus tan alpha by 2. Did we make any mistake? Yes, this is actually, okay, just a minute. This sine A cos B cos A sine B. So this should have been cos of sine of alpha by 2 minus alpha. Since we have written sine of alpha minus alpha by 2, we'll multiply it with the minus. What is sine of minus theta equals to? Sine of minus theta is equal to minus of sine theta, right? So that's what you get. This is what you get. Is that all? Yes, this is minus sine alpha by 2 upon cos alpha by 2, which will become minus tan alpha by 2, as you can see over here, right? What else? There are two terms which remain. Let's simplify them as well. This is minus tan alpha by 2. Again, I'll take the LCM, which is cos alpha by 2. This becomes minus sine alpha by 2 cos alpha. Plus, the cos alpha by 2 will go over there. This is cos alpha by 2 sine alpha. That's what you get in the numerator. This is sine A cos B minus cos A sine B. Okay. Now in this case, it is sine alpha cos alpha by 2 minus cos alpha sine alpha by 2, which is sine of alpha minus alpha by 2. This is sine of alpha minus alpha by 2 over cos alpha by 2 here. Right? This is what you get. Right? This is what you get. This is sine of alpha by 2 cos of alpha by 2, which will convert to tan alpha by 2. Yes. What else? The last term also will be actually convertible. Yes. Let's take the LCM over here as well. This is cos alpha by 2. Yes. What about the numerator? Sine alpha by 2. In the denominator, you had a cos alpha by 2. On taking the LCM, that will go over there. This will become cos alpha times cos alpha by 2 plus sine cos alpha by 2. And on seeing this, what you have is this is cos A cos B plus sine A sine B, which is cos of A minus B, cos of alpha minus alpha by 2. In the denominator, you have a cos alpha by 2. Yeah, that will remain as it is. And what you obtain is, this is cos alpha by 2, this is also cos alpha by 2, both will get cancelled, this is 1. It will be equal to 1. Right, yes, we have compared each and every term. This matrix over here is equal to this matrix, hence proved. That is one more step you can write over there. This is equal to this matrix, and that's the complete proof for this question over here. Yes, you can note the complete proof. This is question 18 from exercise 3.2. Pretty interesting, yes. Some long calculations, Some simplifications, some trigonometric simplifications are involved over here, and let me get aside for a bit for you to take a look at the complete solution once again. That's all. Yes, that is all in this question over here.